Find nth term of following series. Good morning. Welcome to the session. One, 1, followed by 3, followed by 2, followed by 5, followed by 3, followed by 7, followed by 5, followed by 11, followed by 8, and what is next? If you closely observe it, you can find that first term is Fibonacci term, second term is prime term. So the series has alternately Fibonacci and prime terms. The terms at even positions are prime, the terms at odd positions are Fibonacci. Nth term, if n is odd, it is Fibonacci term. If n is even, it is prime term. So suppose you want 11th term. 11th term is 6th prime term. What does it mean? If n is odd, example 11, 11 by 2, 5 plus 1. So n by 2 plus 1 Fibonacci term. If n is even, n by 2 prime term. Okay, let us do it without mentioning any words. So start. Okay, first read the term number. Let it be n, which is obviously an integer. Okay, and pass this term to the function to find out nth term. Okay, now let us write the function. Define. Let us write the function. Define f input is n. Okay. If n is even, then return prime n by 2. Else return Fibonacci n by 2 plus 1. Okay. Now you need prime function and Fibonacci function. Let us write prime function first. Define prime. So you want nth prime term. Okay. Assume that prime numbers so far generated are 0. So while number of primes generated are less than n, required number of primes, then start with a counter, a k. If k is prime, if k is prime, then number of primes generated so far is equal to 1. Okay, and increment k by 1. Right? Now return what you understand, that you need to return k minus 1. You need to return k minus 1. Okay, because after finding k as prime, so we are incrementing, so it should be next. Define is prime, because is prime is required for for define prime. So is prime. Say if we have done it many times, if n is less than 2, return false. Otherwise, start with 2 while I is less than are equal to half of n, then if n is divisible by I, then return false. Return false. Sorry. So else increment I by 1 or take next I. So after checking with all i's which are less than half of n, you return true. Okay. Now this completes the prime part of the program. Then let us write Fibonacci function. Let us check what name we give. Name is yes Fibonacci. So you want nth Fibonacci number. So have one array initialized to 0 with n plus 1 elements. Okay. Assume that fib 0 is already 0. So let fib 1 is 1. Now for I in range 2 to n plus 1, that is 2 to n, fib I is equal to fib I minus 1. So fib 2 is equal to fib 1 plus fib 0. Fib 0 is already 0 and fib 1 is 1. So fib 2 is also 1. Okay. Now return fib n. Okay. So everything is done. I'm sure there may be some mistakes. So number of terms I want, save it here. Say number of terms. I want 11th term. Okay. So what happened? Fib is an array. N must be an index. Fib is an array and n must be an index. Okay. So this is fib I minus 1 plus fib I minus 2. So 11th term is 6th Fibonacci term. 1, 1, 2, 3, 5, 8. Very good. Next. 14th prime term. 7th. 2, 3, 5, 7, 11, 13, 17. Absolutely fine. Okay. So thanks for watching.